Good morning. Can you hear me? Okay. Okay. Good morning. Can you hear me? Dinul? Dulen? Yeah. Good morning. Okay. First of all, let's move into discuss about our final essay question of past paper. Not past paper, exam paper. Again, you have another exam after complete heat lesson. Okay, after a complete heat lesson, that means this is May second week of next month, right? Okay. Okay, first question we already discussed yesterday. Question number 2. Write the equation which can be obtained from the Newton's second law of motion and define each term. Okay, Newton's second law. Do you remember the Newton's second law? The law? The principle? Yeah, what's the Newton's second law? Newton's first law explained about balance object. Do you remember? Balance object, right? This. Newton's first law explained about balance object. If any object rests, or he explained in the first law about rest objects, right? Rest or uniform velocity objects. Actually, he explained what is the Newton's first law. If any object, what he explained? Anyone remember? Newton's first law. If there is no any unbalanced force act on any object, rest objects are rest and moving objects are moving with uniform velocity, right? This is the first law. That means if there are no any unbalanced force, no any resultant force, rest object rest and moving object, if it is moving, it's only moving with uniform velocity. But if you come to Newton's second law, in the Newton's second law, he explained about fully accelerated objects. Accelerated object. That means it has unbalanced force. It has unbalanced force, like this. If it is has unbalanced resultant force, the object has acceleration. Object accelerating or deceleration. Okay, I think you can remember in first lesson I explained about rest objects, uniform velocity object, accelerating object and decelerating object. Decelerating objects. I told rest and uniform velocity objects always Newton's first law. Newton explained in the first law, rest objects and uniform velocity objects. Accelerating and decelerating object. It is the velocity change with time. These objects explained in the Newton's second law. Newton's second law, right? First law and second law. Right. That's a summary. In the question, that's a past paper question. In this question, the question is, what is a Newton's second law? Actually, you don't need to mention Newton's second law. In word, you don't need to mention, but you can remember, right? You have remember what he explained. In Newton's second law, he explained about accelerating object. Yes, he explained accelerating object. What's the law? If any object has unbalanced force or resultant force, the object accelerating, right? Object accelerating, this acceleration directly proportional to the unbalanced force and this acceleration inversely proportional to the mass of the object. Okay, this is a Newton's second law. Very simple. If an object has unbalanced force or resultant force, definitely it is accelerating. Definitely it is accelerating. This acceleration directly proportional to unbalanced force and acceleration inversely proportional to the mass. Okay, that's a inversely proportional. If it is, this is a proportional mark, that one, this is a proportional mark directly with unbalanced force, inversely with mass. Okay, according to this two relationship, we can get an equation F equal ma. This is the equation of Newton's second law. This is the answer for first part. Okay, not only equation, the meanings also ask. Okay, what is the meaning of F? You have to write like this. This is the equation. Then you have to define each term. Define each term. What's the name of F? What's the name of F, Vihander? What is the name of F of the Newton's second law equation? F. Yes, external unbalanced force, not only force. Force wrong actually. Force wrong. The external unbalanced force or unbalanced force. The perfect answer, external unbalanced force or resultant force. External resultant force. That one also correct. External unbalanced force. External unbalanced force or resultant force. Resultant force. Resultant force. External resultant force or external unbalanced force. Okay, what's the meaning of M? It is easy. M equal mass. Mass. A equal acceleration. 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 Right. Okay, this is a complete answer for first part. The Newton's second law equation F equal ma. They are the meanings of each term. Meanings of each term. Okay. Part 2. Part B. A crate with a mass of 400 kilogram is kept on a trolley with a mass of 100 gram located at the position A. Located at position A. Okay, this is a trolley and crate. Crate mean object, right? In a warehouse, a trolley with the crate which is initially at rest. Trolley at crate, both initially at rest. Initially at rest. It is very important. Both objects initially rest. Initially at rest. Is pushed by a uniform horizontal force to the location B. See, the A point to B point, it is pushing by uniform horizontal force, right? Uniform horizontal force. Are you any? Are there? Now we discussing our final exam, final question, right? අපි exam එකක් තිබ්බ ඒකේ final question එක තමයි මේ කරන්නේ. After that, within 15 minutes we can come to the lesson. මේක නිකන් බලන්න. Hari. Okay. Using uniform horizontal force to the location B and then allow to move freely closer to lorry, use the transportation, then using the use for the transportation. Then only the crate will be loaded into the lorry using crate. Only crate. What is the crate mass? It is 400. Miyagi mass is 400 kilogram. 400 kilogram is the mass of crate. Crate means whatever object, right? Okay. Consider the gravitational acceleration as 10 Newton per kilogram and the cos 60 and sin 30 equal half. That you already know. Cos 60 and sin 30 both half. Hari. Okay. Calculate the momentum at location A and B if the velocity of the crate is 2 meters per second at B. The velocity of the crate at B at this point. Method. Think this is trolley at point B and this object. This is a crate, sorry, this is a crate. And its velocity is given velocity 2 ms minus 1. 2 ms minus 1 it is given. Then assume that the energy lost during the moment between the position A and B is 0. There is no any energy loss. There is no any energy loss. The question asks what are the moment of point A and point B separately. It is very simple. This essay question you have to clearly show your answers. Clearly show your answers like this. හරියට ලියන්න ඕනේ essay question එකක්. Therefore you have to show your all steps, not only answers accepted, right? You have to mention all steps. Okay, this is a part B, clearly mention your question number and answer number part 1. Part 1, you can write A point momentum. A point momentum. A point momentum. Not only answer, please understand to me how to answer for essay questions. Some students only writing final answers. You don't have marks. You have to mention all steps in order. Order with showing all steps. For structured essay, you can use short methods and answer indirectly. But for essay question, you have to mention all steps and show your knowledge. Actually, this is a time because you're learning more than 2 years, but you have to answer only 3 hour paper. You have to show your all knowledge by this essay paper because MCQ and structured essay very short questions. MCQ selection, structured essay short questions, but essay question you can show you all potential. Okay, A point momentum. A point momentum. What is the momentum equation? What's the momentum equation? Momentum. Madhya, what's the momentum equation? Momentum. Yes, P equal mv. Momentum mean P. Good. P. Make a on it now. P equal m into v. You have to mention this equation. You have 2 marks for this first equation. Okay. Then mass. How about the entire trolley and crate mass? It is 500 because the trolley mass 400. See, the trolley mass 400. Sorry. The crate mass 400 and trolley mass 100. Then overall, this overall trolley, now it is 500, right? Now overall mass is 500. M equal 500. 500 kilogram. 500 kilogram. 500 kilogram. 500 kilogram into velocity. Velocity. What is the initial velocity? Mariam, what is the initial velocity? The starting velocity? It is given. Nabil, what's the starting velocity? I have highlighted it. It is starting from rest. Then what is the initial velocity? 0. Initial velocity 0. Initial velocity V equal 0 ms minus 1. M equals 0 minus 1. At B point, its velocity 2 meters per second, right? This is an exam question. Now it is 0. 0. Therefore, the initial A point momentum, it is 0. If you want kg ms minus 1. 0. Okay, this is a complete answer. You can have full marks if you follow these all steps. Okay, the same question again asking the B point, final point. B point momentum. B point momentum. B point momentum. It is mv. mv. What is the mass? Same mass because same object. 500 kilogram. B point velocity 2. 2 ms minus 1. Okay, 500 into 2000 kg ms minus 1. Very simple. Kg ms minus 1 is the unit of momentum. Remember, kg ms minus 1 because mass into velocity. Don't need to remember kg, kilogram coming from mass, meters per second coming from velocity. Understood? Okay, this is the answer for first part of B part first question. Mariam, what happened? Okay, let's move into second part. Let's move into second part. If the time taken to move the crate from A to B is 20 seconds. Now it is very simple. It's just like all our question. If the time taken to move the object from A to B is 20 seconds, calculate the horizontal force. Above question above part mentioned uniform horizontal force applied on the object. Uniform horizontal force applied on the object. Horizontal force applied on the object. Okay, now first of all, the time is given. The time is given. The time is given. Then you can easily calculate the acceleration. No? You can easily find the acceleration. Okay, how to find the acceleration? How to find the acceleration? The velocity change 2 minus 0. This is all our question. Yes, final velocity minus initial velocity. That means velocity change divided by time. Okay, what is the acceleration of this object? Acceleration equal. No, you have to do it on paper. Answer script එක තමයි ලියන්න. Second one, second question. The acceleration of the object delta V over time. Okay, what is the velocity difference? Final velocity 2, initial velocity 0. Time consumption 20 seconds. It is meters per second. ms minus 1. මේ පිළිවෙලට හදන්න ඕනේ. දැක්කනේ ලස්සනට හදන්න ඕනේ paper එකේ. Then you can get full marks without any loss. 2 minus 0, it is 2. 2 divided by 20, 0.1. 0.1 ms minus 2. 0.1 meters per square second, because acceleration equals 0.1 meters per square second. Meters per square second. Hurry. It is acceleration, but what is the question? The question is the unbalanced force or uniform horizontal force. Uniform horizontal force. Then you can use Newton's second law, F equal ma. F equal ma. The F is the unbalanced force, the mass 500 kilogram, the acceleration 0.1 meters per square second. Meters per square second. 500 into 0.1, it is 50 Newton. Kg ms minus 2 mean, I think you can remember, it is Newton. That we call as derived SI unit. Newton අපි කියන්නේ derived SI unit. Derived SI unit means the actual unit kg ms minus 2. Remember, the actual unit kg ms minus 2. But that we can define as Newton because this concept found by Isaac Newton. එයාගේ name එකෙන් තමයි අපි use කරන්නේ. මේක තමයි this is the actual unit. Then we can say 1 Newton equal 1 kg ms minus 2, right? That's why I got the standard unit Newton. The standard unit 50 Newton. Okay. Okay, this method totally correct. You have full marks. But do you have any other methods to calculate this force directly? Do you remember? Anyone? Other method? Do you remember the Newton's second law? We can explain by another method. And another method. You met. Newton's second law. Yes, we can explain by momentum method. Now initial and final momentum already found in the previous part, right? Then that's the easy method. Then wala කවුරුත් හදලා තිබේ මේකෙන් මං හිතන්නේ. Yeah, I have given marks, no issue. But easily you can find by momentum method. What's the momentum method? I think you can remember the external unbalanced force directly proportional to the momentum change rate. What's the meaning of? I did using momentum. Very good. What's the meaning of momentum change rate? Momentum change rate means momentum change divided by time. Momentum change divided by time. That means momentum change. Momentum change means final momentum. Final momentum minus initial momentum divided by time. Divide by time. Okay, what is the final momentum that you already got in previous? 1000. 1000. Initial momentum 0. Time 20. 1000 divided by 20, it is 15. Balan 3 rules. Making it 8 rules again. I got Dinul, I got the short method. Which method you use? First one or short one? First method. Okay, no problem, but it's easy to get. It's easy to get by momentum method because you got the momentum change in the previous part, right? Yeah, that's the best method. No worries, make a marks now, but this is a short and easy method. Momentum change rate equal to the unbalanced force. If the distance between A and B is 20 meters, yeah, the distance between A and B 20 meters, calculate the work done by the above process. Hurry. The displacement is given, right? Displacement is given. Okay, what is the work equation? Work equation. Third part. මෙහෙම ලස්සනට හදන්න ඕනේ order එකට. හරිද? Sometimes you very difficult to mark your answers. I can't find the steps. Relevant steps. අල එක එක ඒවා ලියලා තියෙනවා. If you follow this order, it is very easy to mark it. Then you can, without any marks loss, you can get full marks. මේ වගේ පිළිවෙලට හදන්න ඕනේ step by steps. Okay, the displacement 20 meter. 20 meter, then what is the work equation? Work equal, equations compulsory, work equal the force, applied force multiplied by the displacement into force direction. Work equal FD. Short methods enough, right? Short method equation enough. Okay, F, the applied force already found in the previous part, that was 50 Newton. 50 Newton. And the displacement 20 meters. Very simple. 5 into 2, it is 10. 1000 joules, that means 1 kilojoule. 1 kilojoule or 1000 joule. 1000 joule, because work is a measure of energy. I think you can remember its unit always joule or kilojoule, right? Answer 1 kilojoule. Very simple. They are exam questions. The thing is, understand the question well. The story you have to understand. Without understand the story, you can't answer. Not only that, previous question as well. Previous question also very simple if you understand the story. If you think in very complicated way, it will be very advanced, very difficult. The thing, your thinking and understanding is the base for to solve these questions, right? ඒක නිසා මේ හරි freely mind එකෙන් හිතන්න ඕන. Okay, part C. The crane weight mass 20,000 kilogram is used to lift the crate as shown in the figure. Okay, when you read in this question, you should have imagine, you can imagine the story. Then make කියද්දී ආයේ නැත්තම් 3-4 පාරක් කියවන්න වෙනවා. You have to read this 3 to 4 times. It is, then you can't manage your time. In exam, the time management is the most critical thing, right? You can imagine a crate with mass 20,000 kilogram is used to lift the crate as shown in the figure. Then figure එක බලන්න. මේ තියෙන structure, right? Yeah, this is a crane. This is a crane, the vehicle. 20,000 kilogram. The mass of the boom of PR of the crane is 2,000 kilogram. PR එක හොයාගන්න. This is a P, this is R. Then this is a boom. It is given. This is a boom. It's PR, right? It's 20,000. 20,000 kilogram. The vehicle means crane. It is 20,000 kilogram. The boom can be lever. The lever is 2,000 kilogram. S and Q are the respective points where the masses of the crane and the boom are exerted. S and Q are the respective points where the masses of crane and the boom are exerted. Then S and Q are the force mass exerted points. Okay, that means it is 20,000 kilogram, right? The crane mass 20,000 kilogram. Then what is the weight? The S is a weight acting point. What is this weight? It is 200,000, because I think you can remember W, weight equal mg, mass into gravitational acceleration. It is 200,000 Newton. 200,000 Newton. That's the weight of the crane. That's the weight of the crane. And the Q is the boom mass acting point. The mass acting point of boom. Okay, what is the mass of boom? 2000. What is his weight? What is his weight? Nabil. What is his weight? Yuni. What is his weight? Yeah, weight equal m into g, mass into gravitational acceleration. The gravitational acceleration already given, it is 10. Then what's the weight? 2000 Newton weight. Not 2000, 20,000 Newton, because mass 2000, weight 20,000, right? Wait. It was again, Q is a midpoint of PR. Q is a midpoint of PR. PR means boom, it's midpoint Q. That means weight acting point, right? A vertical cable section mark PD is holding the crate. Yeah, vertical cable section marked as PD is holding on the crate. Yeah, this is a PD. It's a cable, right? And it is going through a smooth pulley connected at P. It's connected to a smooth pulley at P. Where it's P? This is a P. It's connected to a smooth pulley. What's the meaning of smooth pulley? Smooth pulley. What's the meaning of smooth? No friction. Very good. No friction of the pulley. If you understand these points, easily you can answer for these questions. The other end of the cable is wrapped around the cylinder connected with the motor. The crate can be lifted by rotating the cylinder. That means when rotate the cylinder, the crate can be lifted, right? What is the work done in lifting the crate to a height of 3 meter? Height of 3 meter. Good, Nabi. What is the work done in lifting the crate to a height of 3 meter? What is the work equation? Work equal FD. But the problem, we don't know weight, we don't know force now. Work equation, C part 1. C part 1. C part 1. Okay, work equal F into D. Force multiplied by the displacement in force direction. But the problem is we don't know force. Displacement is 3 meter. It's lifting 3 meters up to lorry. Lorry or whatever. It's lifting from 3 meters from ground level, right? Then what is the force? What's the force? Vihinga. What's the force? How do we find the force? Mariam, any idea? How to find the force? No, Dinu. 400 mass. The crate mass is 400. This is a cable and this is a crate. It's 400 kilogram. Right? And this is a smooth pulley and everything. Quickly. 4,000, good. Okay, think this is a ground level. It is lifting to 3 meter above point. 3 meter above point, right? Understand, if you get the work by FD method, remember force is equal 4,000. 4,000 into 3. It is 12,000. Very simple. If not, this is a base method. This is a base method. I told the work, if you can't directly find work, force or displacement, you can use mechanical energy difference. Work done by the object. Make a very important point. The work done by the object equal to the mechanical energy, total mechanical energy difference. What's the meaning of total mechanical energy? Potential energy plus kinetic energy. Potential energy plus kinetic energy. But at ground level and 3 meter above point, 400 kilogram, both points, the object rest, right? Rest. Therefore, no kinetic energy. Therefore, I'm going to get final total mechanical energy minus initial total mechanical energy. Okay, that's a base method. Base method. Final total mechanical energy minus initial total mechanical energy. Okay, tell me what is the final total mechanical energy? 3 meter above point, potential energy plus kinetic energy. But this object no velocity, therefore no kinetic energy, right? It has only potential energy. What is the equation? mgh. Work equal mgh minus initial total mechanical energy. At initial it is ground level and it is rest. No velocity. No velocity into upward direction. It is rest. Therefore, what is the total mechanical energy? 0. Right? Then W equal mass 400, gravitational acceleration 10, the perpendicular height 3 meters. Then it is 12,000 joules. That means 12 kilojoule. 12,000 joules or 12 kilojoule. Understood this second method? Yeah, in the lesson I already explained. Remember this point, very important. The work done by any object, the work done by any object, it's always equal to the total mechanical energy change of object. Making up objects. Total mechanical energy change. That means final total mechanical energy minus initial total mechanical energy equal to the work done by any object. Work done by any object. Right? Dinul? No problem. No problem. Mention me. If you use MGH, you have marks. Lakuna dila nithin. Okay. Now you can note down. This is a theory. The work done by any object equal to total mechanical energy change. The total mechanical energy at ground level, it is mgh. Sorry, ground level it is 0. Sorry, ground level it is 0. 3 meter above point mgh, that's potential energy. This is the work done. This is the work done. You met? Okay. Okay, let's move into next part. Calculate the length of the crane boom. It's very simple. This first question. There is a crane boom. This lever length asking. Okay, the angle 60. And what is its length? What is its length? It is already given 10 meter. 10 meter. 10 meter, and this length is asked. It's a right angle triangle. Part 2. හරියට හදන්න ඕනේ in order. Okay, this is a crane. This is a crane. This is a base. And think it is a right angle triangle. This angle 60 degrees. This length 10 meters. Then question asks PR. PR. Okay, you can use trigonometry, right? Trigonometric ratios. What is the best ratio? Opposite over, sorry, adjacent over hypotenuse, cos 60 equal adjacent 10 over hypotenuse, PR. Cos 60 half, it is given in the above part. 10 over PR. Then PR equal 20 meters. It's simple. $20. Simple. Okay. The radius of the crane cylinder used to wrap the cable is 50 centimeters. What torque must be applied on the cylinder to lift the crate? What torque? How about the torque requirement to be applied on the cylinder to lift the crate? Okay. Okay. Third one. Third one. Okay. Torque. Torque. Torque, we have two equations, right? Tau equal Fr and tau equal I alpha. Tau equal Fr and tau equal I alpha. Maybe tau. This is a tau. Torque symbol. Okay, what is the base equation? Best equation. Now you already know F 4000, right? Because this is a cylinder. This is a cylinder. No, this is a cylinder. This is a pulley. This is a pulley. And this is a crate. It's 400 kilogram. 400 kilogram in the weight, 4000 Newton. If it is uniform velocity moving, actually it is moving with uniform velocity. Therefore, the tension also 4000 Newton. It is balanced system. It's a balanced system, right? It's a balanced system. Now, the question asks, what is the torque required on the motor, right? Torque required on the motor. The radius, the cylinder, make a mehengihin connected in the cylinder. It is connected with the cylinder, right? It's connected with the cylinder like this. Okay, the cylinder radius is given. Cylinder radius here. 50 centimeter. 50 centimeter means it is 0.5 meters. You have to convert 0.5 meters. 0.5 meter is the radius, right? Okay, the question asks the torque requirement. The torque requirement. Okay, what is this force? It is 4000 because tension. It's a balance system. 4000 Newton. 4000 Newton. Then you can use FR equation. FR. Simple. The force 4000. The radius 0.5, that means 50 centimeter, that means 0.5 half. Then it is 2000 Newton meter. The Newton meter is the standard unit of torque. Remember? Okay, Mariam, Nabil, understood? Yeah, they are not very complicated questions. Simple, just theory asking me. But this question, forcelism, it's a combination. Always this type questions coming in the exam. Make a force lesson, it has force lesson and work energy power. Finally, rotational motion as well. See. Oh, stuck. Now. Okay, what is the tension on the vertical cable section PD carrying the crate? That you already found. The tension equal 4000 because it's moving uniform velocity. The tension equal 4000. No calculation required. 4000 Newton. The crane will be toppled. This is a question. This is the most important question. The crane will be toppled. Toppled mean rotate or parallel. Toppled about the axis of F. This is a F axis. This is a F. This is F. Toppled about F axis when the mass of crate exceed a certain limit. If it is exceed than certain limit, the crate will be toppled. The crane will be toppled, rotating, right? It will be unbalanced. That's actual meaning. It will be unbalanced. Unbalanced means parallel. Calculate this maximum limit. Calculate this maximum limit. Very simple. Maybe. Okay, I'll draw this diagram on our answer script, right? Okay, our final part 5. Okay, you can draw any sketch diagram or any your helping diagrams in your answer script. No any problem. And the one tarang papers use kalla, you can draw any diagram. Therefore, you can use this method. Okay, I'm going to draw a sketch diagram of this force system. Now it is very complicated. Okay, I'm going to draw a very simple diagram. This is a F point. This is a F point. This is a F point. Think this is a F point. This is a F. 3 meter right side, 3 meter away at right side, 3 meter, right? This distance given 3 meter. There is a force into downward direction. It is 200,000 Newton, right? Now I can mark this force 200,000 Newton. 200,000 Newton. It's a perpendicular force. 200,000 Newton. 200,000 Newton. 200,000 Newton, right? Next one. What else forces? 10 meter above, 10 meter on the crate. Okay, the total 20 meter, this is a midpoint. Q is a midpoint, then it is 10 meter, right? 10 meter, there is force. That's a not a perpendicular force. What is this angle? Can you send me this angle? This angle between this Q force and boom. What's this angle? Amar? Yes, it is 30 degree because if you complete this as a right angle triangle, 60, 90, the remaining angle is 30, right? 30 degrees angle. If you got 10, yeah, this is the total boom. It's 20 meters. 20 meters. 10 meter, there is a force with 30 degree. The value is, what is the value? Okay, the value is 20,000. 20,000 Newton. Yeah. And it is 3 meter. Now F2, this final point 3 meter. What is, how about this length? It's 10 meter. 10 meter. Right? Okay, there is another force 10 meter away, because total length 20. This point to F point, it's 20. Then the Q is a midpoint. This is a Q. Q is a midpoint. Right. Okay, perfect. Okay, what is a, yeah, මෙතන තමයි අපි crate එක එල්ලන්නේ. That's the point we hold the crate, right? Hanging the crate. Now it is 400 kilogram in the experiment, in the practical, but according to final question, they asking maximum limit. The maximum value asking. වැඩිම amount එක. Maximum weight. Then I'm going to add mg. Then if you got the m, that is a maximum weight. Okay, think, sorry, it is not perpendicular. It's not perpendicular. It's not perpendicular. That one also m g 30 degree angle. Do you have any doubt up to now? How it's coming 30 degree or whatever? Nabil? Amar? Mariam? Quickly, quickly. We don't have time. Today we have a lesson. Vihanga, understood? Okay. Why I got 30 degree angle? Because it is not perpendicular to boom. That's why. It's not perpendicular to boom. Right. Yeah, it is not perpendicular. See, it's not perpendicular to boom. That's why I got angle. Right. Okay. Now, if it is balanced system, I explained about in the lesson, force lesson, moment of force. Now think it is a balanced system. Now, if it is balanced, we can calculate them. We can calculate them, right? If it is a balanced system, we can calculate the m. We can calculate them. Think the f is a fixed point or rotating point. My fixed point is f. Okay, I'm going to get moment of force around f point. Moment of force around f point. I think my reference direction, clockwise direction. Therefore, I'm going to add clockwise moment of forces plus and anti-clockwise moment of forces negative, right? Minus. Well, 200,000. Clockwise only 1. Therefore, 200,000. 200,000 into 3 equal to, this is clockwise moment of force, equal to, the sum of clockwise moment of force is equal to sum of anti-clockwise moment of force. 200,000, sorry, 20,000 and mg both anti-clockwise. Rotate to left side, anti-clockwise. you have to resolve these both forces into this way. දෙකම resolve කරගන්න වෙනවා. Because they are not perpendicular forces. They are not perpendicular forces. Now 20,000 resolve it in this way. Send me equation. 20,000 resolve it in this perpendicular way. Quickly. Force 20,000 resolve it in this way. You meant? Quickly. Vihanga? First resolution. Deal. No, Dinul. Yeah, 10,000 because 20,000 we are not going to resolve it into angle direction, opposite direction. Matakai me put it there. This is a force resolution. This F and theta. Angle direction always F cos theta. Matakai the opposite direction F sin theta. F sin theta. The same concept. Come again. 20,000 sin 30. 20,000 sin 30. 20,000 sin 30 mean half, right? Sin 30 half, it is given in the question. Question everything is given. 20,000 sin 30 is given, it is half. 20,000 sin 30 half, that means 10,000. 10,000 into 5. Because length 5, sorry, 10. Because length, the perpendicular distance 10. Plus mg resolve it into this way. mg sin 30. mg sin 30 means half mg. Into what is the distance? That is the most important point. What is the distance of mg? mg force distance here. 10. Quickly. Yeah, 20 because always the moment of force means the force multiplied by the perpendicular distance to the rotation point, to the reference point. Then mg to f distance. In previous point, I got q to f distance. Then mg1, mg to f distance is 20. Yeah, that's the equation. If you got mg, easily you can find mass, right? 600,000 equal 10,000 into 10, 100,000 equal, may I cancel into 10 mg. 10 mg. Now 100,000 get into this side, it is 500,000 equal 10 mg. 0 to 0 cancel out. 50,000 equal to mg. mg equal 50,000 Newton, because mg mean weight. Then the g equal 10. M equal 10 equal 50,000. Newton, 0 to 0 cancel out, then M equal 5000 kilogram. M equal 5000 kilogram. Understood? Any doubt? That means the maximum limit of the cable 5000 kilogram. If you hold 5001 kilogram object, the crane will be tripled. Crane will be rotated, right? Understood? Send message. Okay, actually, this question I did very complicated way. This is a amarva method again. But you have another simple method. In the exam time, I explained this simple method. Amar, what happened? I got good mark. But do you remember during the exam time, exam meeting, I explained another method, easy method. Yeah, I'm going to erase that. Yeah, I told without force resolute කරන්න නැතුවත් හදන්න පුළුවන් කියලා. Can I erase? Yeah, without resolution you can get this same answer like this. මෙහෙමත් පුළුවන්. මේ බලන්න. If you draw the rough diagram, sketch diagram this way, it will be very simple. If you draw this way, now this is a F point, this is a F point, and this is 200,000 Newton, and it is 3 meter. This part okay, this part same for both method, but this part, my left side, it's given the perpendicular distance already 10 meter, the boom distance, the boom length 20 meter. Yeah, this paper very simple. Yes, it is very simple than previous exam. Yeah, the total length of the boom 20 meter, but the perpendicular, this is both forces acting towards the gravity direction. This is for perpendicular distance, right? Perpendicular distance already given. Okay, if it is 20 meter, what is this perpendicular distance? It's 10 meter. Perpendicular distance only 10 meter, right? Now you can draw like this. Get only 10 meter distance in left side, and this is the F rotating point, and this is the 20,000 now. This is perpendicular now. 20,000 perpendicular, but the length is 5 meter. 5 meter. Right? And this is another 5 meter. It is empty. This is short method because the perpendicular length already given. I got, if you use this method, the same answer 5,000 enough. If you got the slant boom, this is a method. If you got the perpendicular length, this is a method. Then the clockwise momentum force 600,000, 20 into 5. Anti-clockwise momentum force 100,000. It is 5 mg. 5 mg. 5,000 5,000. Okay, that's the end of exam number 5. The main thing you have to practice how to answer for essay question. Now MCQ questions we practice lot of MCQs, you are doing well, but essay questions I hope to give you next exam structured essay questions as well, because you have to ready and practice how to answer for again answer එක sometimes you can't get full marks due to you not following correct order, right? They are the mistakes. Then already done, but you are doing mistakes when you're writing. Okay, now. Okay, now we are going to start our lesson. Okay, what we discussed, we are discussing heat energy lesson, our 8th lesson, no? Right. In heat lesson, we discussed the basic part, what's the meaning of heat, what's the meaning of temperature. Do you remember what's the meaning of heat? Heat is a type of energy which is formed due to temperature difference. That's the definition of heat energy. And heat always transfer from high temperature to low temperature. Always these are heat direction. Heat direction. And that's the heat direction. Yoni, are you there? Okay, now we're starting the heat lesson. But we discussed 2 parts of heat lesson. I'll give you send me message after class. I will give you previous 2 recordings, and you can continue. Okay. Now we discussing about thermal expansion. The first part in heat lesson we have 3 main steps, 3 main parts. The first one is a thermal expansion. Now we discussing the volume expansion, right? Okay, heat energy. Let's revise past lessons, past day. Okay, heat energy. Heat energy always transfer from high temperature to low temperature. That's the heat direction. Sun to earth. Sun temperature 6000 Celsius, earth temperature -80. That's why it's transfer from sun to earth, right? Yeah, we discussed many examples. What else? What we discussed? The heat always transfer until thermal equilibrium. Do you remember? Thermal equilibrium mean, think if you mix 2 substance, think it is 30 Celsius. If you add iron block with 100 Celsius, which one heat releasing? 100 Celsius metal block or water? Which one heat releasing? Which one heat releasing? Metal block. Why? Always heat transfer from high temperature to low temperature. Then metal block heat release. This release heat absorbed by water and container, right? This release heat absorbed by water and container. I told the heat always transfer from high temperature to low temperature, and it is continue up to thermal equilibrium. Matakai? It is given in the tube. It is continue up to thermal equilibrium. Thermal equilibrium means this metal block release heat and water absorb this releasing heat, and finally it's come, both substance come to a same temperature. That we called as thermal equilibrium. Thermal equilibrium, right? Okay. Okay. Now I need the definition of temperature. Can you send me? What's the definition of temperature? Now heat is energy. Heat is a type of energy. It's formed due to temperature difference and it's moving from high temperature to low temperature. What's the temperature? These definitions very important. You should have complete knowledge. Methanida from starting from heat lesson, not like previous lessons. You should have complete full idea about each term and each concept. Vihanga, what's the meaning of temperature? What's the meaning of temperature? Quickly, quick. Yes, the average kinetic energy of molecules of any substance. Perfect. The average kinetic energy of molecules of any substance. Okay, great. Okay, what's the meaning of average kinetic? Sorry, there was a connection failure. Now, can you hear me? Okay, I told you solid, liquid or gas, whatever substance, if it is heated, what happens is heat energy absorbed by particular substance. And we have a special principle as energy conservation law. Do you remember in work energy lesson, we discussed energy conservation law. Energy conservation law means energy cannot be created, whatever energy type cannot be created or destroyed, right? Now, this energy absorbed by molecules, this energy absorbed by molecule, I think the same thing I explained third or fourth time, but this basic concept very important for understand the entire lesson. That's why again I explain every day. Okay, think every molecules, I think you can remember every molecule made by every substance, solid, liquid and gas, everything made by molecules, and this molecule, if it is heated, if you provide heat energy, this heat energy absorb this heat and it's convert, cannot be create or destroyed, right? Energy conservation law cannot be destroyed actually. This absorbed heat convert into kinetic energy. The kinetic energy is a type of mechanical energy. I think you can remember. Kinetic energy is a type of mechanical energy. This heat energy convert into mechanical energy. It's a vibration. Then start to vibrate this molecule and increase their vibration. The temperature is a measure of this vibration, molecule vibration, kinetic energy. A measure of this molecule kinetic energy. If we provide continuously heat, what happens? This continuously absorb heat and it's convert to kinetic energy. Gradually, this kinetic energy increasing. That's why the temperature, we can observe the temperature of substance is increasing. Clear? Madhyam? Simple. Okay. Then what's the meaning of thermal expansion? Our last week lesson. What's the meaning of thermal expansion? Okay, I told whatever substance, solid, liquid or gas, when it is heated, now you already know it, this heat energy convert into kinetic energy and increase their vibration, increase molecule kinetic energy. As a result of this molecule kinetic energy, what happened? The molecule distance, intermolecule distance, the distance between molecule is increasing, the gaps increasing. Due to that, what happened? Due to this reason, the size of any substance, size of any solid, liquid or gas is increasing. The space taken in the surrounding is increasing. Actually, the volume is increasing. Can you size එකෙන් වැඩි වෙනවා? Expand වෙනවා. That we called as thermal expansion. Okay, according to Mete type, thermal expansion 3 types. What are the types? Yeah, I told all material types, all material substance are expanding. Therefore, we have 3 methods: solid expansion, liquid expansion and gas expansion. Okay, last week we discussed about solid expansion. Solid expansion mainly 3 types. What are the types? Solid expansion 3 types: linear expansion, area expansion and volume expansion. Liquid and gas expansion only has only one type, it's volume expansion only, because liquid cannot expand as a line or area. Liquid or gas cannot expand as a length or area, therefore it has only, therefore they have only volume expansion, right? You all have tubes, right? Tubes samam kya hoti hai na? Okay, I gave homework. I complete. How many questions I gave? Yeah, before that I will revise our 2 equations. 2 equations. The linear expansion. What's the meaning of linear expansion? The linear expansion. Very simple. The linear expansion. The linear expansion. Okay, before that, please understand this chart. This is our summary of the lesson, right? This is a summary of the lesson. Wait. Yeah, this is a summary of the lesson. Page number 4. Thermal expansion 3 types: solid expansion, liquid expansion and gas expansion. Solid expansion 3 types: linear expansion, area expansion and volume expansion, right? Liquid and gas only has a volume expansion, right? Okay, this is a summary. Okay, I will quickly revise what is the meaning of linear expansion. Linear expansion. Linear expansion. Okay, actually, what's the meaning of linear expansion? That means delta L, right? Delta L. Delta L. Linear expansion. Linear expansion means increase in length with temperature. Increase in length. This is the initial length L1. I think you can remember L1. Comment. L1. Initial length at theta 1 temperature. If it is heated up to theta 2 Celsius, theta 2 means final temperature. If it is heated, it's converted to theta 2 L2 length, the final length, L2, increasing in length. Okay, that's the meaning of linear expansion. This increased length, we called as a delta L. This is a linear expansion. Okay, I told 3 main factors affect on linear expansion. What are the factors? Matakai? Initial length, weight, L1. What else? Initial length, material type and the temperature. difference, temperature difference. Three main factors, they are given in the tube. There are three main factors affect on linear expansion, temperature difference, material type, and initial length. Okay, initial length. I told initial length and L1 and temperature difference both directly proportional with delta L, right? Delta L. This is a base. This is the base of the equation. According to that, I can write delta L directly proportional to the L1 and delta theta. L1 and delta theta. Right? Then we have a specific equation. Delta L equal. I'm going to convert this proportional mark to equal. Then it is delta L equal L1 and at constant. What is a constant? Alpha. Greek first alphabet lesson. Greek first alphabet letter. Alpha. Not A, alpha. Delta L equal L1 alpha delta theta. Alpha delta theta. What's the name of alpha? What's the name of alpha? What's the name of alpha? Yes, the linear expansion coefficient. Linear expansion coefficient. We made a short note, right? අපි හැදුවා නැති short note එකක් මේකේ. Up to area expansion we did, right? Yeah. හරි. Now, can you define the area expansion? It is linear expansion coefficient. Linear expansion coefficient. Linear expansion coefficient. Can you define this? What's the meaning of alpha? Alpha equal delta L over, do you remember that? Delta L over L1 delta theta. Alpha equal delta L over, delta L over L1 delta theta. Then how we can define it? Alpha. The linear expansion of any substance of unit length. Yes, unit length while increasing the temperature by 1 degree Celsius. Yes, great. No need to remember. If you can remember this basic equation, you can create these definitions. Definitions hada ganna puluwan. You only need the basic concept. Hadana විදිය විතරයි දැනගන්න ඕනේ. Yeah, increase of the unit length of any object when temperature increase by 1 unit or 1 degree Celsius. Great. Perfect. This is a linear expansion coefficient. Linear expansion coefficient. Finally, we got another equation. I think you can remember that. That means L2 equal L1 plus delta L. That's simple. That means initial length plus increased length equal to the final length. Next. Do you have any homework question related to this? Linear expansion in Dunal? Dinul? එකක් දුන්නා නේද? 1 or 2? Fine. How many questions? Expansion mechanism. You met linear expansion complete करा दे. Yeah, this is a table. No, as I remember, we have only one or two questions. Vihange. Dinul. second one and third one. එක තමයි ඇහුවේ. Second one and third one. Yeah, we can discuss. Third one. මේ දෙක. හරි. Now this one discussed. Third B and below. මේ දෙක නේද? මේ දෙකද? Yeah, that's only. Others discussed, right? Right. Okay. We have only B part. හරි කමන්නේ. අපි මේකේ before calculate B part, we have to calculate part A as well. Otherwise, we can't find the linear expansion coefficient. හරි. අපි දෙකම හදමු. මේ දෙක විතරක් හදමු. And let's move into the area expansion. An iron rod of initial length 120 centimeter, and when its temperature is increased from 0 to 100 Celsius, 0 to 100 Celsius, the increase in length 1.52 millimeters. Find the linear expansion coefficient of iron. හරි මේක හදමු අපි ආයි මතක් වෙන්න. The linear expansion coefficient is asking. It's alpha, right? It's alpha. Now delta L equal, what is our basic equation of linear expansion? Delta L equal L1 alpha delta theta. Right? What is the delta L now? The increased length. An iron rod initial length 120 centimeter, and when it is temperature increased from 0 to 100, the length increased by 1.52 millimeters. 1.52 millimeter is the delta L, expanded length. The alpha is asking. But the problem, the delta L given in millimeters, initial length given in centimeters. Therefore, we have to get both into same unit for substitute. අපි ගමු මේක centimeter කරමු. 0.152 centimeter, right? That's the delta L. Delta L. 0.152 centimeter is the delta L, equal to L1, 120 centimeters. Alpha is asking, alpha done stone. Delta theta 0 to 100, temperature difference 100 Kelvin. Now centimeter to centimeter cancel out. That's why I got in same unit to cancel out. 0.152 equal 120 into 100 means 12,000. 12,000 alpha equals 0.152. Now alpha equal 0.152 divided by 12,000. Then what is the alpha value? ටක් ගාලා ගන්න. එද හැදුවා මේක මම. 0.152 divided by 12,000. Send me as a power value. Yeah, 1.26 into 10 to the power minus 5. 1.26 into 10 to the power minus 5 per Kelvin. This is a linear expansion coefficient of which metal? Iron rod. Iron rod. Area expansion of iron. Sorry, linear expansion. Iron. Okay. Let's move into part B. There are rails of a railway are covered with iron. උඩ හෙව්ව iron වලින් තමයි හදලා තියෙන්නේ. හරිනේ iron වලින් කොහොමද හදලා තියෙන්නේ? Okay, when the ambient temperature increase to 90 Celsius, 90 Celsius, the gap between rails gradually disappears. Disappears again. The gap will be filled with iron. Filled with iron means expanded at 90 Celsius. What is the total gap between the rails of the length of 1 kilometer at 0 Celsius? At 0 Celsius, within 1 kilometer, what is the gap requirement is asking. Again, always we have to maintain gaps, small gaps between rails. Rail period අතර gaps තියන්න ඕනේ. ඇයි? If it is no gaps in daytime, in heat condition, they evaporated, then if not they change the shape. They change in the shape due to expansion. Therefore always we have to maintain gaps between. You can check if you're going to railways, you can check always they maintain gap between each rail iron rod. හැම rail පීලකම gaps තියෙනවා. Question asks within 1 kilometer, the gap requirement will disappear at 90 Celsius. 90 වෙද්දි gaps නැති වෙනවා. How to calculate? Simple. B part. Same equation, delta L equal L1 alpha delta theta. Okay, can you tell me delta L we don't know because delta L is asking the gap requirement. L1, the complete length of railway, 1 kilometer. 1 kilometer. 1 kilometer means how many meters? 1000 meters. 1000 meters. Alpha, iron linear expansion coefficient, you already got 1.26 into 10 to the power minus 5. 1.26 into 10 to the power minus 5 per Kelvin. Per Kelvin is the alpha unit, remember. Per Kelvin. Per Kelvin. Per Kelvin. Multiplied by temperature difference. What's the temperature difference? It is gap disappears at 90 Celsius. The gap asking at 0 Celsius. Then 0 Celsius. I mean 90 is the temperature difference. 90 Kelvin. Kelvin to per Kelvin cancel out. Then answer coming in meters. 1000 into 1.26, it is 126. 126 another 0 into 90 into 10 to the power minus 5. Okay, make a value එක දාන්න. Use calculators. 1260 into 90 multiplied by 10 to the power minus 5. 1.134 meters. 1.134 meters. But it is not a practical answer, no? Practical. Because normal temperature 90 වගේ වෙන්නේ නැහැ. Normal temperature 35 වගේ නෙවෙයි. එතකොට අපිට පොඩි ප්‍රමාණයක් තමයි තියන්න ඕනි gap එක. But if it is increase up to 90 Celsius, normal daytime temperature, we have to maintain 1.134 meter per 1 kilometer. Okay, note down. Okay. The railway tracks will not be volume expansion. Yeah, it's possible to volume expand thickness as well. Can you hear me, right? Yeah, it's possible to expand thickness, but to increase thickness, they have space. The length enhancements is a problem. Length එක වැඩි වුණාමනේ මේ gaps ඕනේ මෙන්. Gaps required for length expansion. The volume also expanding, but for volume expansion, there is space. You can track එකේ මෙහෙමනේ තියෙන්නේ. This is one railway track. This is another road. For volume expansion, they have space. The length expansion is a problem. Linear expansion is a problem. That's why we need to maintain gaps. Yeah, good question. Understood? Okay, let's move into area expansion. Okay, what's the meaning of area expansion? Eketh short note hadala ඇත්තනේ. Area expansion. hadala නැත්තේ දුලේ. Yes. Okay, I'll revise. Area expansion. Area expansion. Area expansion means delta A. Delta A. What's the meaning of area expansion? The increase the size of any object, length and width. Length and width both sides. Length and width both sides we called as the area expansion. Okay, this is the initial. This is the initial area A1. This is the increase area. Length and width both sides. It is A2. A2 after expanded. And this is a theta 1 initial temperature, theta 2 final temperature. This is the expanded area that we called as delta A. For area expansion also, we have three main factors affected. What are the factors? What are the factors? Initial area, temperature difference and material type. Same as linear expansion. Very simple. Initial area, temperature difference and material type. Same as linear expansion, the initial area directly proportional to the A1. So direct temperature difference also directly proportional to area expansion, temperature difference, delta T. Yeah, according to that, according to this relationship, we can get an equation delta A equal, delta A directly proportional to A1 delta theta. A1 delta theta. Now we can modify this equation delta A equal A1. Instead of this proportional mark, we can add the constant. What is this constant? Beta delta theta. What's the name of beta? Yeah, this equation delta A equal A1 beta delta theta is the area expansion equation. What's the name of beta? What's the name of beta? The area expansion coefficient. In previous equation alpha, it is linear expansion coefficient. Second, in the area expansion, it is area expansion coefficient. Area expansion coefficient. Area expansion coefficient. Okay, I need now the definition of beta. The definition of beta. Beta equal delta L over, sorry, delta A over A1 delta theta. Okay. Area expansion coefficient, beta. What is the definition? The area expansion of any substance, increase in area of any unit area while increasing the temperature by 1. Always may dividing factors become 1. Unit unit 1. The area expansion delta A of any substance of unit area while increasing the temperature by 1 degree or 1 unit. Wait. Okay, this other thing, the most important, the other thing, do you remember I told always beta equal to alpha? That's the most important thing. Always beta equal to alpha of any substance. As example, now think what is the iron linear expansion? Iron linear expansion was 1.26 into 10 to the power minus 5. Then what is iron area expansion? What's the iron area expansion? It's 2 times. 2.52 into 10 to the power minus 5. 10 to the power minus 5 unit. 5 need. Yeah, it's iron beta of iron. It is 2.52 into 10 to the power minus 5. It's 2 times. Understood? Any substance beta value, it's 2 times than the alpha value. Okay, clear. Okay, we discuss up to this level, right? Dule. अब मेथड वितरण करें नहीं you met? You want to discuss up to this point, right? Okay. Okay, before moving to homework questions, let's move into volume expansion. Then the solid expansion completed. Okay, write down in your short note the topic solid volume expansion. Volume expansion. Volume expansion. Volume expansion. Delta V. Delta V. Okay, what's the meaning of volume expansion? What's the meaning of volume expansion? Can we continue today up to 11:30? I will look at class 9. Let's continue up to 11:30. Then we can complete expansion too. Then liquid expansion we can start next week. Hurry. Okay, volume expansion. Delta V. Okay, what's the meaning of volume expansion? It is same thing. Same thing. Think in linear expansion, increase in length. Area expansion, increase in length and width both two sides, two dimensions. In volume expansion object volume expansion. This is a volume expansion. This is a theta 1 initial temperature. If it is heated, theta 2 up to theta 2 temperature, it is increase in size, length, width and height, all dimensions, 3D dimensions, 3 dimensions increasing. Length taking value, like this, length and width and height increasing. That's why we called as it is delta V, and this is a delta V. This increased amount is delta V, volume expansion. This initial volume V1, same as previous, and this final volume V2 at theta 2 Celsius, volume V2. Right. Now, what is the meaning of volume expansion? Go to the tute. Volume expansion. Yeah, this is a volume expansion. Increase in the volume, 3 dimensions. Any solid object when temperature increase called as a volume expansion or volumetric expansion. Yes. Okay, this is a story. Right? Increase in 3 dimension, length, width and height, all dimensions. That we called as volume expansion. Volume expansion. Now, volume expansion also, there are 3 main factors affected, same as previous. There are 3 main factors affect on volume expansion as well. What are the factors? Think here. The initial volume, factors affected on factors affected on volume expansion. Okay, what is the first one? Initial volume. What is the symbol? Initial volume. It is V1. V1. The second one. Temperature difference. Temperature difference. Temperature difference. Temperature difference means delta theta. Temperature difference means delta theta. Third one, matter type. Matter type. Matter type, no symbol. Actually, it is gamma. I'll show you that. Okay. Same as linear expansion. While increasing the initial volume, what happened? The amount of molecule in the initial object is increasing. Therefore, the space taken also increasing. I got the scientific reason. When you increase the initial volume, the number of molecules increasing. The initial the number of molecules increasing. Therefore, the kinetic energy also getting increased, the space getting increased. That's why when you increase the initial volume, the delta V, the volume expansion also increasing. That's why we call delta V, V1 directly proportional with delta V. Understood? The volume expansion also getting increased because huge number of molecules. I got you mean the reason the number of molecule is greater. You know, you and me. Okay. When increase the number of molecules, that's the story. Again, number of molecules වැඩි වෙද්දී expansion වෙන්න පුළුවන් ability එක වැඩි. The reason huge number of molecules, therefore they getting more space between molecules, right? Yes, great. That's the reason. Linear expansion area also same reason. Hard. Now it is directly proportional, right? Okay, if you got temperature difference, easily you can understand that one also temperature difference directly proportional with delta V. Linear expansion and temperature difference directly proportional. That's easy. When increase the temperature difference, delta V is increasing, right? Okay, according to these two relationships, I can make a equation. Both delta V equal. Therefore, delta V directly proportional to the V1 delta theta. Now I can remove this proportional mark. Delta V equal to the V1 gamma delta theta. This is my equation. Delta V equal to the V1 gamma delta theta. V1 delta can make only. Delta V, it is same as previous equation. Delta V equal to V1 gamma delta theta. V1 delta V equal to V1 gamma delta theta. This is a gamma. Matakan alpha, it is equal to A alpha. Mehem alpha in beta gamma, right? Can delta V equal V1 gamma delta theta. Delta V equal V1 gamma delta theta. Okay, now can you suggest what is the name of gamma? What is the name of gamma? Yes, simple. Volume expansion coefficient. කලින් වගේම තමයි. Volume expansion coefficient. Volume expansion coefficient. Okay, quickly note down up to now. Complete. Sorry, not V1. මේක change වෙලා arrow එක. Gamma is the volume expansion. Mariam, complete. Okay. Now write down the topic, the volume expansion coefficient within bracket gamma. The volume expansion coefficient within bracket gamma. Gamma. Okay, now what is our basic equation? Delta V equal V1 gamma delta theta. Okay, please isolate the gamma. Isolate the gamma. Isolate the gamma. Gamma tanikara. Okay, what's the equation? Delta V, same as previous. Delta V equal V1 delta theta. Delta V equal V1 delta theta. Delta V equal V1 delta theta. Now, can you define the gamma? Can you define the gamma? The volume expansion of any substance of unit volume when increasing the temperature by 1 degree Celsius, right? The same thing. Okay, write down the definition of, write down with star mark. Write down with star mark. The volume expansion of any substance of unit volume, the volume expansion of any substance of unit volume while increasing the temperature by 1 degree Celsius. 1 degree Celsius is called as the volume expansion coefficient. While increasing the temperature by 1 degree Celsius is called as the volume expansion coefficient. Second point, this is a constant depend on the material type. This is a constant depend on the material type. It's a constant depend on the material type. Final point, third point, any substance gamma mean volume expansion coefficient, right? Any substance gamma is equal to 3 times of 3 times of linear expansion coefficient. 3 times of linear expansion coefficient, that means alpha. Any substance gamma is equal to 3 times of linear expansion coefficient of same substance. Same substance. A substance එකේම linear expansion එක වගේ 3 times. That means 3 alpha. I got right. Now you can write මෙහෙම ලියලා කොටු කරන්න. මේක ලියලානේ තියෙන්නේ. Gamma equal 3 alpha. Gamma equal 3 alpha. Gamma equal 3 alpha. Example. Alpha of iron. මතකද කීයද කියලා? 1.26 into 10 to the power minus 5 per Kelvin. Beta of iron 2.52 10 to the power minus 5 per Kelvin. Gamma of iron, same material. What's the value? Gamma of iron. Gamma of iron. Amar 3.78. Great. 3.78 into 10 to the power minus 5 per Kelvin. Yeah. Write down this one. Complete. And the unit, same unit, එකත් දාලා තියන්නේ gamma unit. මෙතනින් දාන්න equation එක ගාවින් gamma unit equal delta V cubic meter into Kelvin. The unit cubic meter to cubic meter cancel out, per Kelvin is a unit. Per Kelvin is a unit. It's same unit. In linear expansion, volume expansion, area expansion, all coefficients, per Kelvin is a unit. All right, complete. Dulen. Okay. Now let's move into our final topic of the lesson. Final length. Final volume. Final volume. Final volume. V2. Final volume. V2. Final volume. V2. Okay, what's the final volume? We can get easy equation V1 plus delta V, increase volume. V1 plus increase volume, delta V, it is equal to V2, right? V2. Now, කලින් වගේම තමයි. V2 equal to V1, initial volume plus increase volume, delta V. This is my first equation. Then I can create another equation, V2 equal V1 plus delta V වෙනුවට අපි දාමු instead of delta V I can add V1 gamma delta theta, our common equation. V1 gamma delta theta. Then V2 equal V1 you can get into out of bracket, then 1 plus gamma delta theta. This is my final equation. Okay, write down. Okay, that's the end of theory part of solid expansion. Now you have another homework. You have another homework. Homework එකේ තියෙනවා තව part එකක් නේද? Volume expansion කියලා part එකක් තියෙනවා. Linear expansion complete. Now you have 1, 2, 3, 4, 5 homework questions. And if you not completed, මේකත් ඉවර කරන්න ඕන. Area expansion. Next week we're going to discuss all homework questions and start liquid expansion and gas expansion. Next week is the end of final part of expansion අපිට ඉවර කරන්න පුළුවන් within next week. After that we go into the second part of heat lesson. Heat lesson is a very long lesson. No any advanced things, all are simple, but it's a long lesson. Okay, do you have any doubt today? Yoni, I got what happened? Okay, you can go through previous two parts and you can get the full idea and continue. Send me message what you're doing, how you complete other previous parts. Previous part mean we have 6 lessons. Yeah. Others, any doubt? No. Okay, let's meet next week with the final part of expansion. If you have missed any part of expansion, please go to recordings and complete and prepare well for the final part. Otherwise, you will be confused when we're doing complex calculations. Okay, goodbye.